Welcome to Easy Elimu Learning Simplified. My name is Eric. I'll be taking you through this topic, coordinates and graphs. And for this particular lesson, we're going to cover graphical solutions of simultaneous equations. So this is something that we have done before. We have done solutions of simultaneous equations. We've looked at two methods. One is elimination method. We've looked at substitution method. Now we are introducing the third method of solving for unknowns in a given set of simultaneous equation called graphical method. So this is graphical method of solving for unknowns in a given set of simultaneous equations. So we want to see how that is done. So we have a few questions on the same to help us with illustrations on how that can be done. And of course, at the end of this lesson, we'll be having some questions in the form of assignment just to help you with practicing and just to help you check on your understanding of the concept as we're going to discuss during this uh, during this lesson. So we say that the linear equations, when you want to solve for unknowns in the given set of simultaneous equations, using a graphical method, then what you do is that you try to draw the two graphs on the same Cartesian plane, and then try to establish the point of intersection. We're talking about point of intersection of the two graphs. So you draw the two graphs and then check where they intersect. Of course, normally when you draw two graphs on the same Cartesian plane, if they have uh, solutions, like if you're able to find the solutions even using elimination method and substitution method, it means even it should be possible to find the solutions using graphical method. Otherwise, if it's not, then when you try to draw them, they may not really intersect. But if they intersect, then the point of intersection becomes the solution. Rather, you simply extract the coordinates. So we talk about the coordinates of the point of intersection of the two graphs. That is if they are drawn on the same Cartesian plane. So you draw one and then you draw the other one. Then where do they intersect? That becomes the solution of that set of simultaneous equations. So a good example is this one here. Solve the following pair of simultaneous equations using a graphical method. So you just draw the first graph. Okay, so it's here. We talked about this in the previous slide. Previous lesson, we were talking about straight line graphs. So the procedure that we did, possibly if you didn't get that, you can check from that. Our previous slide, you'll be able to see how that is done. So draw the graph of x plus 3y is equals to 5. Also draw the graph of 5x plus 7y is equals to 9. And then after that, you extend the two lines so that they are able to intersect. The point of intersection will be able to give us the solution for the given set of simultaneous equations. For example, these two lines, they meet at the point negative 1, 2. See, negative 1 and then 2, the positive side of y-axis. So the x coordinate here becomes the x value and the y coordinate becomes the y value. So we can conclude and then say x is equals to negative 1 and y is equals to 2. You cannot leave your answer that way. You have to extract, because remember we are trying to find the values of x and y that can satisfy both equations. That is equation 1 and equation 2, just like we did with the elimination method and substitution method. So draw the two graphs on the same Cartesian plane and then extend them so that they're able to meet at a point. The point of intersection will give you the solutions of the given set of simultaneous equations. So let's look at this example here. So what we will do is I'll draw the two graphs separately. So I have the first one, y is equals to 3x minus 1. So what we did in the previous case is that we drew a table. So generate that table with so that is the first table. So I have x and y. For values of x, you said you can just select them randomly. So I'll use the least three values on the number line. So we have -1, 0, and 1. Then from there, I'll be able to solve for corresponding values of y. In this equation, when x is -1, I will have -1 by 3, -3 minus 1 is -4. When x is 0, 0 by 3 is 0 minus 1 is -1. When x is 1, 1 by 3 is 3, 3 minus 1 is 2. So I should be plotting this on the Cartesian plane, but because there are two equations, I will have to find the other table first, and then I'll be able to plot the two. So now this one is 2y. So I can divide all through by 2 to have y plus x is equals to 1. Then x can move to the other side. So y is equals to 1 minus x. Then you can then go ahead and draw the table. So -1, 0, and 1 values of x. Then y I will solve using the equation. So when x is -1, I will have 1 minus minus 1 because x is -1. So 1 minus minus 1 is 1 plus 1, which is then x is 0, 1 minus 0 is still 1. X is 1, 1 minus 1 is 0. So I have the points -1, 2, 0, 1, and 1, 0. So you try to plot them. So first thing, or what you do first is to draw the Cartesian plane. So that is the vertical axis, what we are calling the y-axis, and then the horizontal axis. So that is the x-axis, this is the y-axis. So we have 1 here, 2, 3, 4, 5, 6, 7, -1, -2, -3, -4, -5, -6. I have -1, -2, -3, -4, -5, -6. I have 1, 2, 3, 4, 5. Now I can plot after that. After labeling the axis, we can then go ahead and plot. So I will begin with the first table. So -1, -4, -1, -4, somewhere there. Then 0, -1 is here. And then 1, 2. So just draw a line that passes through the 3 points. So you label the line after you've drawn, you label. So y is equals to 3x minus 1. I will also do the plotting with the other one as well. So this is the second table. So -1, 2. So -1, 2 is up here. And then we have 0, 1 is here. And then 1, 0 is here. So it's just a matter of drawing a line that passes through the 3 points. And once you do that, you remember to label your line. So y is equals to x minus 1. Now with this, now you can be able to extract the coordinates at the point of intersection. So point of intersection is this, P. Coordinates can be given as 0.5, x, and y is also 0.5. So you already have the x value. So you just extract and talk of x equals to 0.5, and y is also equals to 0.5. If you try to substitute these values into the equation, you should be able to find the exact values. You know, the solutions are supposed to be satisfying both equations, equation 1 and equation 2. This is 1, 0.5 by 2 is 1, 0.5 by 2 is 1, 1 plus 1 is 2. Let's check the first one, 0.5 on this side, the other side is 0.5 by 3 is 1.5 minus 1 is 0.5, which is equal to 0.5. So that is how you go about it. And a few questions are here to help you practice on what you've been learning during this lesson. So you can always attempt when possible. Otherwise, that marks the end of the lesson. Until next time.